In ancient times, animals evolving in the sea formed bones in order to protect themselves. Their lives were maintained by minerals contained in abundance in the sea water. As time passed, they gradually came out of the sea and began to live on land. In the course of time, they formed bones inside their bodies rather than outside, so as to move more easily and support their bodies. At the same time, bones came to assume the role of regulating minerals, so that body fluid would not be affected by environmental changes. Bones are constantly remodeled with the help of various hormones, thus maintaining their host's life. Bones are hard tissues in which crystals of calcium and phosphorus are deposited and adhere to stroma, consisting of collagen. A cross-section of a bone shows us that there are a lot of rings in the hard tissue. In each of these calcified rings, there are thousands of osteocytes. Each osteocyte has lots of long and fine projections and receives nutrients and oxygen from blood vessels in the center of the ring. When polarized, black and white streaks appear. Why do these streaks appear? Because the arrangement of collagen fiber differs from place to place in the bone. Those streaks indicate that bones are formed in layers. This time, a bone is cut vertically. The inside of a bone is filled with tissues called bone marrow. Many blood vessels run through it. These vessels enter into every nook and corner, carry out calcium stored in the bone, and carry back nutrients and oxygen to cells working in the bone. The vessels are also indispensable for cells to destroy old bones and form new bones. Then, let us observe how blood vessels are formed inside the bone. Leukocytes and lymphocytes shine brightly. They are actively moving around in tissues surrounding blood vessels. Other cells are now working hard in order to form new vessels for supplying nutrients and oxygen to the bone. "18 hours have passed since observation began. To the left below, a blood cell which came out of a vessel is moving upward. The cells have formed a narrow tube, and blood cells are being squeezed out of a wide blood vessel and thrust into the tube one after another. The cells are moving up and up through the tube. A new blood vessel has been formed in the direction of the bone. The bone is receiving nutrients and oxygen from blood running through this vessel. This vessel is also carrying back calcium stored in the bone to cells. Calcium is one of the indispensable materials for cells to perform their various functions. Cell division. Division of cells occurs when calcium flows into the cells. Similarly, calcium activates nerves and the contraction of muscles. Pulsating heart muscle. The contraction of cells continues as long as calcium is provided. However, the contraction rhythm of heart muscle cells becomes slow and irregular when the calcium amount outside the cells decreases, and finally, contraction ceases. In order to maintain normal functions of cells, the amount of calcium contained in body fluids should be kept at an adequate level. Let us cut a bone into a round section and observe how a bone is remodeled. Cells living in the bone are destroying the bone rapidly. Bones are not only supporting our bodies, but also working as a utilizable store of calcium which regulates body fluids. When the amount of calcium in body fluids decreases, bones provide the fluids with calcium stored in them, thus making the balance steady. 16 hours have passed. The bone, which looks dark, has been destroyed from inside and become very thin. The storehouse for calcium, that is, the bone, is constantly remodeled. In other words, bones are changing all the time, keeping a balance between resorption and formation. "28 hours have passed since observation began. The bone is seen only as an outline. Although the bone is being destroyed as we have seen, it is also being formed at the same time. A month after, a new bone is formed in a place where an old bone was, and is actively depositing calcium. As we have seen, cells remodel bones without changing their former shape. Osteoclasts and osteoblasts are working busily around the new bone. The process of remodeling of bones is deftly controlled by vitamin D and other hormones. Here, let us observe how hormones work upon bones. Vitamin D is added to bone marrow cells in vitro. Pay attention to the cell marked with an arrow. The cell is moving upward. Two vertically adjacent cells have fused into one. The fused cell again comes together with neighboring cells one by one, thus forming a multinuclear giant cell. The giant cell spreads its membrane and comes close to a bone. Let us observe how the cells fuse with one another in a magnified picture. Multinuclear cells are incorporated into a still larger cell. The activity of the cells produced by vitamin D is not easily calmed down. A multinuclear giant cell is dissolving the bone. This means that the giant cell has now become an osteoclast. This is a high magnification of the osteoclast. Vacuoles in the osteoclast are incorporating bone stroma and dissolving it. The bone has been so dissolved that it has become very thin. The osteoclast is still working hard in order to destroy the bone completely. Now the osteoclast seems to be releasing bone elements vigorously. Let us see how another osteoclast is working. It seems that the osteoclast is creating a high acidity environment in a space surrounded by its membrane and the bone. As a result, calcium contained in the bone is dissolved and flows into the space, and the acid disintegrates the stroma. To the left below, a macrophage is approaching an osteoclast. When observed closely, it seems that the macrophage is receiving small vacuoles from the osteoclast. Is the macrophage helping the osteoclast, or is it working in its own way in order to absorb the bone elements? The osteoclast is actively dissolving and absorbing the bone. Calcitonin was added to the cultures. Pay attention to the cell membrane marked with arrows. The membrane stops moving. It also seems that the cell is not absorbing bone elements anymore. But no special change is observed in the movement of mononuclear cells around the osteoclasts. As we have seen, in our bodies there are hormones which activate the disintegration of bone by creating osteoclasts, and also hormones which suppress their activities. These hormones stimulate cells as the occasion demands and control metabolism of bones. Vitamin D, which stimulates bone resorption, also activates osteoblastic cell function. Undifferentiated cells, which have been repeating cell division, become osteoblasts when enough vitamin D is supplied. Newly born osteoblasts soon begin to secrete a large amount of protein, including collagen. Collagen and other organic materials secreted by osteoblasts have got together and made what looks like a thick bundle. As the culture time lengthens, the osteoblasts become enclosed in bone stroma, which they have made, and grow into osteocytes. Now, bone stroma has been formed. Calcium and phosphorus adhere to the stroma, thus forming a mature bone. Osteocytes are seen inside the calcified bone, and each of these has lots of fine and long projections. This is a section of a normal bone. When vitamin D is deficient, bone stroma cannot be calcified normally. A bone with imperfect calcification is thin and fragile. Cells working busily in order to remodel bones. Cells never stop working as long as we're alive. During the long history of development and evolution, bones have acquired a lot of important functions. Bones that had been formed by cells played their own roles and sustained his life. Now the cells have gone forever, and only the bones remain, leaving memories of their host's life in an eternal flow of time. Memories of a man who led his life sometimes in grief, but often in happiness.